In this video, let's go ahead and practice finding vertical and horizontal distance on a coordinate plane together. For number 1, we have these 2 points, A and B. A is going to be at -4, +3. If we go ahead and plot that first point, that's going to be 4 to the left from the origin, and then 3 up. So point A is going to be here in quadrant 2. And then for point B here, we have 7, +3. So that's going to be starting at the origin, 7 to the right, and then 3 up. So here is where B is going to be. So we're going to go ahead and find the distance between these 2 points, but we're going to have to use absolute value. We're going to go ahead and make sure we're adding or subtracting. That's what this says in the directions where it says sum or difference. We're going to make sure we're using absolute values as well. Okay, so we could just count it on the coordinate plane, but we're going to use a little bit of calculations using some knowledge that hopefully we have at this point. All right, so when we're doing this, let's make sure we see what is matching. We have matching y coordinates here, so that makes it so that we can find the distance between these 2 points. So they have matching y's, which means these are horizontal points to each other. So then let's go ahead and find the distance between these non-matching values, which is this -4 and 7. So if we go ahead and take the absolute value of -4, and then we add that to the absolute value of 7, because they're in different quadrants, this will give us the distance. Now the absolute value of -4 is just going to equal +4. That's how far it is from 0. And the absolute value of 7 is going to be 7. Now 4 plus 7 is going to be 11. So it's going to be 11 units, or 11 units apart from each other. And if you wanted to count this on the coordinate plane, you can see that this is going to be the 4 units, and that this over here is going to be the 7 units. So 4 plus the 7 over here does get you that 11. Let's check out number 2. For number 2, we have this point of C, which is -9, 8. So let's go ahead on the coordinate plane. That's going to be 9 to the left, and then it's going to be 8 up. So it's going to be right up here. That's point C. For point D, we have -9, +1. So -9 is 9 to the left, and then up 1. So that's going to also be in the same quadrant. So here's D. All right, so what matches here? We can see that they have a matching x value and x value. So when they have matching x values, these are vertical points to each other, so they're up and down. So these are the matching ones. Let's go ahead and use the 8 and the 1 to find the distance between these 2 points. So if they're in the same quadrant, we're going to subtract their absolute value. So 8 is further, so absolute value of 8 minus the absolute value of 1. Now absolute value of 8 is just 8. 8 minus the absolute value of 1, which is 1, is going to be 7. So this is going to be 7 units. If you want to count this, go ahead and do so, but you can see from C to D, we have 7 units in between. All right, for E, what do we have? We have -1, -7. Let's go ahead and plot that. -1 is 1 to the left of the origin, then 7 units down. We go ahead and plot this one. This is going to be E. That's down in quadrant 3. And then for F, we have -1, +8. So that's 1 to the left of the origin, then 8 units up. So here's F. Okay, so let's go ahead and see what we have that's matching. It looks like they have x's that are matching, which then lets us know, just like in the last example, these are vertical points to each other. And so these are matching. So let's go ahead and just look at their non-matching numbers, -7 and 8. They're in different quadrants, so we're going to add their absolute values to find the distance. So the absolute value of -7 plus the absolute value of 8. The absolute value of -7 is 7. The absolute value of 8 is 8. And 7 plus 8, that's going to be 15. So it's going to be 15 units away from each other. And if you want to, again, count that, you can see from 8 to 0, that's going to be 8 units. And then from 0 to -7, that's 7 units. So 8 plus 7 is 15. Okay, so let's take a look at number 4. We have G, which is at 5, -8. So that means we're going to go from the origin, we're going to go 5 units to the right, and then we're going to move 8 units down. That's going to be in quadrant 4. Here's G. And then we can take a look at H, which is 5, -1. So we're going to start at the origin. We're going to move 5 units to the right, 1 unit down. Here is H. All right, they're in the same quadrant here. You can see they have matching x's again. The last few examples seem to have all matching x values, just a coincidence. And so these match. So we're going to go ahead and use this -8 and -1 to find the distance between these 2 points. So they're in the same quadrant since they're both negative. So we're going to go to take the one that's further, which is absolute value of -8, and take away the one that's closer to 0, which is the absolute value of -1. The absolute value of -8 is 8, and the absolute value of -1 is 1. So 8 minus 1 is going to be 7. So these 2 points are 7 units apart. If you look over here, you can see that they are indeed 7 units apart if you want to count them. All right, one last one of these types we have for number 5, we have I, which is 0, 8. let's see, 0, 8 is going to be on the positive y-axis, right? So we're going to start the origin, move 8 units up. So that's going to be this point right over here. That's going to be I. And then for j here, we have 10, 8. So that means we're going to start the origin, move 10 to the right, and then 8 up. I'm going to put that point right over here. That's going to be j. All right, so let's see, what do we have that's matching? It looks like we have a y value and a y value that are matching. So that means these 2 points are horizontal to each other, or left and right of each other. And let's go ahead and use the 0 and the 10. Now, these two numbers, because we're technically one of them's on the y-axis, it doesn't really matter if you add or subtract. So that's an interesting point to kind of take note of, that if something's on the x-axis or y-axis, it doesn't really matter if you're adding or subtracting the absolute values. I'm just going to go ahead and subtract here, just because, again, it doesn't really matter. So I'm going to go ahead and subtract these absolute values. Absolute value of 10 is 10, absolute value of 0 is 0, and then 10 minus 0 is going to be 10. So we have 10 units. Again, you can see hopefully that from I to j, you can see that this is 10 units across from each other. All right, cool. Let's take a look at this next section. All right, so here we're going to go ahead and do the same thing we were doing. However, we're going to have maybe some fractions and decimals here, as well as we don't have a coordinate plane. So feel free to grab some graph paper and plot these to help you. But I'm going to go ahead and just use the absolute values like we were just doing. So for number 6, we have these 2 points, and notice here that they have these matching y values. And so you can try to imagine it. That means that these 2 points are going to be left and right of each other, or horizontal. And we're going to go ahead and just compare and use these two numbers here. So are these in the same quadrant or different? Well, one's negative and one's positive, so they're in different quadrants. So think back, are we going to add or subtract here? We're going to be adding. So the absolute value of this negative 5.5, so how far is that from 0? Plus the absolute value of 8.5, how far that is from 0. And they're in different quadrants, so we're going to add them. And the absolute value of negative 5.5 is 5.5. The absolute value of 8.5 is 8.5, and if you add these two together, 8.5 plus 5.5 is going to be 14. So it's going to be 14 units apart from each other. Okay. If we look at number 7, what is matching here? Let's see here. It looks like it's going to be the y values again. So we have these two negative 1s, which means these 2 points are also going to be left and right of each other. And so we're going to go ahead and compare these two. Now, they're both negative, right? So if they're both negative, that means they're in the same quadrant. If they're in the same quadrant, we're going to subtract their absolute values. Now, which one do you write first? I recommend just going ahead and writing the one that's further from 0, which is negative 8, and take away the one that's closer. This way you end up with a positive number. Now, if you flip-flop them by accident, that's okay. Just, I guess, take the absolute value of your answer, and that will be fine. So the absolute value of negative 8 is 8. The absolute value of negative 3.5 is just 3.5. And if you go ahead and subtract these two numbers from each other, 8 minus 3 is 5, right? So 8 minus 3.5 has to be half less than 5, so 5 minus a half, that's going to be 4.5 units. Now, if you needed to go ahead and write improper fractions, get common denominators, you can do that too. But hopefully that also makes some sense there. All right. For number 8, we have these 2 points, and we're going to see what is matching. We've got some decimals here. Looks like the x's are matching here. So these 5.9s are the same value. So I'm imagining that these 2 points are on kind of up and down from each other, or vertical. And we're going to go ahead and just compare this negative 3.2 and 7.5. So are they same quadrant or different? Well, one's negative, one's positive, so they're different. So we're going to take the absolute value of negative 3.2. Let's go ahead and add the absolute value of 7.5. Right? The absolute value of 3.2, negative 3.2 is going to be 3.2, and the absolute value of 7.5 is 7.5. And if you add these two decimals together, they're not too bad. 3 plus 7 here is 10, and then 0.2 plus 0.5 is 0.7, so we don't have to carry anything. So I think we're getting 10.7 units apart here. All right, cool. Let's take a look at number 9. For number 9, let's see, we have these 2 points. Do we have something matching? I think here it's going to be the y's. This y is negative 5.5, and this y is negative 5.5. And so just like 6 and 7, these 2 points are technically going to be left and right, or horizontal to each other. So let's go ahead and see if we can find the distance between these two. Now, are they the same quadrant or different? One's negative, one's positive, so they're different, and we're going to add their absolute value. So the absolute value of 3 1/4 plus the absolute value of this negative 5.5. is going to get us a distance between these 2 points. So the absolute value of 3 and a fourth is going to be 3 and a fourth plus, and the absolute value of negative 5 and a half is going to be positive 5 and a half. So 5 and 1/2. Now, instead of this 1/2, we're going to need common denominators here. So hopefully that makes sense. We're going to go ahead and times this one by 2 and by 2, because 2 and 4 meet for the first time at 4, right? So we're going to go ahead and say this is going to be 3 and 1/4 plus 5 and 2/4. And if you add these two together, 3 plus 5 is going to be 8. And then this 1/4 and 2/4 is 3/4, so it's 8 and 3/4 units apart. All right, here's number 10. All right, for these problems, we're going to go ahead and be writing 4 ordered pairs, 4 points that are going to be the exact distance from each of the given points. And basically to do that, we're going to find one point that is above this point, one point that's below, one point that's to the left, and one point that's to the right. So we have this point of A, which is 5, 6, and we want to go 3 units that's above it. And we only take a look at the Y value here, and we have to go 3 above here. So if you went up 3 from 6, that's going to bring us to 9, right? So if we do 6 plus 3 is 9, and that means the X value is not going to change because we're only going up. So it's going to be 5, 9. Okay. Now, what if we want to go below? If we want to go below, we're still going up and down. So this is the height of this point here, and we're going to go 3 units down. So if you're at 6 and then you drop 3, or you go down 3, 6 minus 3 is going to be 3. So this new point here is going to be 5, 3. All right. So when the points are above and below each other, they should all have the same matching X values. This 9 is going to be 3 more than 6, and then this 3 over here is 3 less than 6. Again, we're looking for points that are 3 units away. Now, what about if we want to go left and right? So for left, that is going to be moving along the x-axis, right? So this number of 5 lets us know the x value are left and right. If we want to go 3 units to the left, we have to look at 5 on a number line and go 3 to the left. 5 minus 3, that's going to be 2. So we're looking at 2, 6, right? The y value is not going to change. Now, if we're going to go to the right now, again, we're starting at this 5, and we're moving 3 units to the right. So on the number line, 3 to the right of 5 is 5 plus 3. That's going to be 8. So we're going to be looking at 8, 6. So when you have these 2 points that are left and right of this original point, notice how they have all matching y values. And then if you look at this 5, this 2 is 3 less than it because we're going 3 units to the left. And then this 8 over here is going to be 3 units to the right of it. Let's try number 11, another example together. All right, so this time we have point B, which is at -2, 5, and we're going to be going 7 units away. So if we're above, we're only looking at this y value, and we're going to go up 7. So 5 plus 7, that's going to be 12. And so we're going to have the same x value of -2, but then we're going to have a y value of 12. Similarly for below, we're going to still stick with this y value. We're going to have to go 7 units down. So if we're at 5 on a number line, a vertical number line, we go down 7. So for this point, we're going to have -2, -2. Now what about if we're going to the left? If we're going to the left, we're going to look at this -2 because that's an x value for left and right. So we take this -2, we're going to move 7 units to the left of it. So imagine if you're at -2 on the number line and you go 7 to the left. If you do -2 and you go 7 to the left, that should bring you to -9. So at this point is going to be -9, 5. All right, and this next one here, we're going to go to the right. So we're going to take this -2 again, and we're going 7 units to the right this time. So if we're at -2 on a number line, again, it's maybe good to draw it if you need to. And move 7 to the right, -2, and you move 7 units all the way to the right. It's going to bring us to a +5. So it's going to be 5, 5. Again, if it helps you to plot these points, feel free to do so, but hopefully it's making a little bit more sense as we practice them. All right, here is number 12. For number 12, we have this point of C, which is -2, -5 over in quadrant 3. And we're going to find 4 points that are 6 units away. Now, for above, let's go ahead and take a look at this y value of -5. If we're going to go above the -5, then we have to go up 6. So if we're at -5 on the number line and we go up 6, that's going to bring us to +1, right? And if you need to draw this out, I really recommend doing so, but that's going to bring you to +1 here. Now, what if you want to go below? If you want to go below, look at the y value again, and we're already at -5. We're going 6 down from that. So if we're at -5, but we go even more negative, that's going to bring us to -11. So it's going to be -2, comma, -11. When you're dealing with all these negatives, it might be a good idea to sketch this out, but if this is also making sense to you in your head or visually, then that's great too. Now, what if we want to go to the left? Well, that's dealing with the x now, right? So we're at this -2, and we're going to go to the left 6 units. So think about where -2 is on a number line, try to visualize it, and then go 6 units to the left of that, which is more negative. That's going to bring us to -8. So we're going to be at -8, comma, -5. And then moving to the right, let's go ahead and take a look at the x value again, and we're going to move to the right 6 units. So 6 to the right, think about where -2 is on a number line, and go to the right. That's going to be becoming more positive, right? So that's going to bring us to a +4. So it's going to be 4, comma, -5. Right? And if you want to check your answer, go ahead and plot all these points and see if they make kind of like that up, down, left, right, kind of looking like a plus sign if you connected all the dots. All right, here is 13. For 13, we're looking at this point of D, which is -2.5, comma 3. We're going 5 units away. So to go above, let's take a look at this y value and go up. So we're going to go up 5 from here. So 3 plus 5, that's going to be 8. So we're going to have this -2.5, comma 8. Then let's go ahead and go below. So still take this y value of 3, but then go 5 units down. So 3, and then 2, and then 1, and 0, and then -1, then -2. So that's going to be -2.5, comma, -2, or 5 below. Next for left, let's take a look at the x value here. And we're going to go 5 units to the left here of that. So it's going to be more negative. So -2.5 is where we start, -3.5, -4.5, -5.5, -6.5, -7.5. So this is going to be -7.5, comma 3. Then moving to the right here, we're going to take a look at this x value again, but we're going to go 5 units to the right this time. So we're at -2.5. If we go to the right, it's going to be -1.5, -0.5, +0.5, +1.5, +2.5. So if we go to the right, that's going to be +2.5, comma 3. Okay, so there you have a few examples on finding 4 points that are equidistant, or the same distance from a given point. All right, here's a few more. So in this section, we're going to go ahead and use this information and try to find the possible values for this variable of n. So in each of these examples, we're looking for the value of n. It says the possible values, so there's maybe more than one, right? All right, so for 14, notice these 2 points. Right away, I'm noticing that they have these matching x values, right? So that's good to know that we can find the distance between these two. And if we do that, then we're just looking at this 2 and this n, right? So basically, we need to figure out the 2 and n, how far apart are they from each other? Well, it's actually interesting. We're told that they are 4 units away from each other, okay? So these are y coordinates, right? So if you go ahead and think about this on a number line, these are y coordinates. And just say you have 2 over here on this y coordinate that we have, and then we have to find 2 things that are 4 units away. So this might help you visualize this, but if we go 4 units up, this would be 3, 4, 5, 6, then we'd be at 6 up here. So n could be 6 if you went up, 4 units here, right? That's up, that's +4. Now that's one way to do it, but n could also be something else, right? Don't we have to also think that we could go 4 units down? So this would be 1, 0, -1, -2. So over here, this point is going to be 4 less than where we currently were before. Okay, so n could also be -2 here. All right, so we're looking for 2 points that are 4 units away from that 2, and n could be either of these because it could be above and it could be below. For 15, let's see what matches. Let's see, it looks like these -6's are the same, which is nice. So these 2 points are going to be left and right of each other this time, all right? We're trying to see, we have this unknown n and 2. What we do know about them is though that they are going to be 7 units away from each other. So there's going to be, what points are going to be 7 units away from 2 along the x axis, basically left and right. So let's go ahead and draw a quick number line. You can see here. And we're talking about 2 again here, so here's 2. And again, we're on the x-axis because we're talking about the x's, and we're looking for things that are 7 units away. So here's 3, 4, 5, 6, 7, 8, 9. So if you were to go to the right 7 or plus 7, then that brings you to 9. So n could be 9, right? Or what's another way we could have gone about this? We could go to the left 7. So 1, 0, -1, -2, -3, -4, -5. So that brings us to -5 if you move to the left. You can see here that's going to be if you went to the left 7. So n could be 9, but n could also be -5, depending on if you move to the left or you move to the right. All right, for 16, let's see what matches here. It looks like the y values match, -4 and -4. And so let's look at the 7 and this n. We have to find the n values that are both going to be 3.5 units away. So if we have matching y values, just like in the last one, then we're knowing that we're looking at x values here. So we're looking left and right. So left and right on a number line. We can draw something like this to help visualize. Let's see, we're dealing with the number 7 here. So here's 7. We're going 3.5 units in either direction. So let's say here is going to be 8, 9, 10, that's 3 units. Here's 11. So I think right in the middle here, this would be what, 10.5? 10.5. And that's if you go from here to here, that's going to be plus 3.5 units, right? So if we had 3.5 units to the right here, n would be 10.5. Now, what if we went to the left? Well, if we went to the left, 3.5, this would be 6, 6, 5, 4. Here's 3, but we need to just go a half there. So that's going to be 3.5, right? So if we went to the left here, that's going to be minus 3.5, or moving 3.5 units to the left here, and you end up at 3.5. So n here would be 3.5. All right, for this last one here, notice that we have matching y values. We have -5.6 and -5.6. So you can go ahead and see these match. Just like the last few, we are going to then look at this -3.4 and n, and they're going to be 6.7 units away from each other here. Okay, so let's think about this on a number line so we can see visually. This is going to look like this, left and right. And we're looking at -3.4 because that's what they give us. And so we're going to be going to the right 6.7. We're going to be going to the left 6.7. All right, so think about this for a moment. If we go to the right, it's going to be more annoying to maybe make a number line with all the little tick marks. So essentially, if we go to the right, we're going to add 6.7 going this way. And then we're going to go ahead and take away 6.7 going to the left here. All right, so that's what I want you to kind of visualize. Now, if we go ahead and say we're at -3.4, but we're going to the right 6.7, well, it's going to take 3.4 to get all the way to 0, right? Once you get to 0, how much more do you still have to go? Well, if you take this 6.7 and take away 3.4, you have already traveled 3.4 to get to 0, but you're also going to then travel 3.3 past 0. Okay, so think about that for a moment. But if you keep going, then you're going to end up at positive 3.3. So that's going to be saying n could be 3.3 if you went to the right. And then what's going to happen if you go to the left? Well, you're at this -3.4, but you're going down more, you're going more negative. So if you're negative and then you go even more negative, you really can just think about this as 3.4 plus this 6.7, right? Now 4 plus 7 is 11, carry the 1, and then 1 plus 3 plus 6 is going to be 10. So we're at -3.4, right? And then we're going even more negative. We should be at -10.1. So if we put a little tick mark here, that's going to be -10.1. And you can see, like, if you were to find the distance between these two, you could subtract their absolute values and you would get 6.7. And over here, if you go ahead and add these two absolute values because they're in different quadrants, you would also get 6.7. So n here would equal -10.1 as well. All right, so there you have a few different practice problems dealing with distance on a coordinate plane. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.